Now that we know what makes the language of mathematics complicated, let's discuss the instructional strategies that teachers can implement to support their students. Explicit instruction is an instructional practice that is defined as being research-supported instruction that provides needed supports for successful student learning through clarity of learning and purpose and reduction of students' cognitive load. Explicit instruction promotes active student engagement by requiring frequent and varied responses, followed by affirmative and corrective feedback from the teacher. There are 16 elements of explicit instruction that are on this slide, and they describe 6 key principles. Number 1, we want to maximize students' engagement on a task. Number 2, we want to promote high levels of student success. Number 3, we want to maximize instructional time or increase the amount of content that we are able to cover within our classrooms. Number 4, we want students to spend more time in groups where they are able to receive more targeted support from the teacher. Number 5, we want to scaffold instruction and systematically fade these scaffolds as students are ready to promote independent learners. And lastly, number 6, we want to address different forms of knowledge so that students can express their knowledge at differing levels, including the declarative level, which is when they describe what something is, the procedural level, which is when they describe how something is done, and the conditional level, which is when they describe when and how and where to use the skill.
This visual explains the explicit instruction practice. It starts with modeling, sometimes known as the I do. Then practice, both guided and independent, the we do and the you do. And throughout all of that instruction, the educator is engaging students in the supporting practices. I'll spend the next few minutes explaining the elements of modeling and the supporting practices that are crucial in supporting language development. For more detailed information on explicit instruction, visit the National Center on Intensive Intervention at intensiveintervention.org for their course content. In the modeling stage of explicit instruction, some of you may interpret this part as the I do. The educator needs to share a clear explanation of what is being learned today and why it is important. Here are some examples of clear explanations about the goal of the mathematics lesson and why it is important. Today, we're learning about division. This is important because sometimes you have to share objects of things with your friends. Let's continue working with our three-dimensional shapes and volume. Understanding volume and calculating volume helps with measuring capacity. If you notice, the educator in these examples does not shy away from using the precise language. We want to present the goal and importance in precise mathematical terms. Next, in the modeling phase, you want to model the steps of a problem. To solve 26 plus 79, first I decide about the operation. Do I add, subtract, multiply, or divide? The plus sign tells me to add, so I'll add 26 plus 79. I'll use the partial sum strategy. First, I add 20 plus 70. What's 20 plus 70? 20 plus 70 is 90, so I write 90 right here. Then I add 6 plus 9. What's 6 plus 9? 6 plus 9 is 15, so I write 15 here. Finally, we add the partial sums. 90 and 15 is 105. So 26 plus 79 equals 105. What you might notice from the script on the screen is the math language used. First, we see 26 plus 79, and then the word operation, all mathematically concise terms. Next, building upon operation by asking add, subtract, multiply, or divide, being both concise and precise with my word choices. These words are all important terminology that the student has to focus in on to solve this problem mathematically. So we want to be sure we're using them during the modeling phase. Notice, I did not add a lot of flowery language And I didn't use invented terms such as timesing or minusing. Students may still use these terms in their explanations. It is our job as educators to model the correct terminology and provide support and guidance to bridge the invented terms into using the precise and concise mathematical language. For the supporting practices in both the modeling phase and the practice phase, it is crucial for educators to ask the right questions. This is a combination of low-level and high-level questions. Low-level, such as, what is 7 times 9? Which shape has 6 sides? And what do you see when you see a word problem? What do you do when you see a word problem? And high-level questions such as, why do you have to regroup? How would you solve this problem? And why do you have to use zero pairs? The next component is eliciting frequent responses, an essential supporting practice. Not only does this help us understand what students know, but helps us guide their thinking to more accurate, precise use of mathematics and mathematical language. Working in a variety of settings and getting responses in more than just verbal, hand-raised, whole class helps to build strong understanding of mathematics. You can do this through individuals, through writing on paper or whiteboards, thumbs up, thumbs down, or even choral responses. So here's some examples. Turn and discuss the formula for perimeter with your partner, write a problem on your whiteboard, or even draw a picture in a math journal. When providing feedback to students in verbal or written form, we want to be sure it is immediate as possible, and it is affirmative and corrective. We want our students to think precisely, so we need to explain with feedback that uses appropriate mathematical language to direct their attention to the mathematics. Good work using your word problem attack strategy. Let's look at that again. Tell me how you added in the hundreds column. And lastly, as Alex stated earlier, some of the essential elements of explicit instruction are making students engaged on a task, promoting high levels of student success, and maximizing instructional or increasing the amount of content that we're able to cover within our classrooms. This is achieved by having planned and organized lessons to ensure we are maintaining a brisk pace. For explicit instruction, you may not always be doing 50% of your instruction modeling and 50% of practicing as shown in the first visual off the top. It all depends where in the progression of understanding is the student for a particular concept. Is it a new concept that you're just introducing to students? Then they'll need more time in the modeling phase. In comparison to reviewing a concept, then they'll need less time in that modeling phase, but probably more time guided practice and independent practice with feedback. For more details about the instructional strategy, explicit instruction, and how to best implement in your setting, see the course content on intensiveintervention.org.